Since we're live, are you guys able to hear me? If someone on the chat can. Okay, thanks, Roberto. Thanks, Pedro. Okay, so I'll start the presentation. My name is Lucas. I work here at RDI as on the DevOps team, and I'll be presenting GitHub Actions to you guys today. Uh, Unfortunately, I don't have a camera on my PC right now, so you won't be able to see my not so beautiful face. So I'll leave that to your imagination. So let's start. So the index. I'll show to you guys what GitHub Actions is, its components, and then I'll be doing a demo for you guys. So first of all, what is GitHub Actions, when we can use it, and how much it costs. So what it is. GitHub Actions is task automation done pretty easy. It's fully integrated with GitHub, so you don't need another tool. So you can use it to build, test, and deploy your applications. So it's basically a solution for all your CI/CD needs. And when it can be used, every time those GitHub Actions are event driven. So any event on GitHub can be a trigger to an action. So if you want to send, you raise a pull request and you want to warn your team, so you can create an action to send a message to their Slack or something like that. If someone, you can create an action for if someone would raise an issues on your GitHub repo to create a Jira ticket automatically. So today it has a lot of events. So any event related to your repo can be a trigger to an action. So like a pull request approval, a pull request comment, and even other actions can be triggered to other actions, if this makes some sense. And outside of that, we can trigger those actions manually. We can have use GitHub APIs to trigger the events as well. So you can have an external tool calling a webhook to trigger an event on your GitHub, and you can have scheduled tasks. And how much it costs? It has 3 tiers today. It's teen. I think it's $4 per person per month. Enterprise, that's $21 per person per month. And there is a free tier that's for people like us who just want to have a repo on GitHub. This free tier gives us 2,000 minutes a month and 500 megs of GitHub packages to upload. But these are only if you're using a private repository, because if your repos are public, it's completely free. Now let's go to the components that makes an action. So basically, an action is composed of workflows, events, jobs, a runner, the steps and the actions. So first of all is the workflow. So the workflow is the procedure, the recipe that you are adding to your repository, to your GitHub repository. It's written in YAML language, and it has a very specific folder that you need to add to your repo. That's .github/workflows. And so what I did here, we are going to build together. We're going through all of these components, and we're building together a YAML file. So this workflow has a name. This is how it's shown on the GitHub Actions page on GitHub. So mine here, I'm going to build a .NET application, so it's called just .NET. Then we have the events. Like I said, those actions are event triggered. They can be branch specific, and like I said before, there is a lot of options on push. So when you push the code, you trigger it. When you raise a pull request, this workflow call here is when you use another workflow to trigger one workflow. And one thing that's cool here is that you can pass down arguments from one to the other. On issue creation, like I mentioned before, like someone raised an issue on your repo, and then this automatically notifies you, or maybe raise a Jira ticket or something like that. On workflow dispatch, this is the manual trigger, and this I added here that this supports manual input, so you can create parameters that you need to not need, but you might add, when triggering that workflow to support and increase the range. It becomes really flexible what you can do using it. Repository dispatch is the API call from an external event. And on schedule, that's when you can schedule workflows to be triggered every now and then. And I just added here, it's used POSIX syntax. It's kind of complicated to use, but on GitHub documentation page, they have like a tool that help you out how to do it. So here on YAML file, it's the events sign as on, and here on my scenario, I have like this to run when we push code to the main branch, or someone raises a pull request to the main branch. Next of all is the jobs. So the jobs is a set of steps that runs in the same runner. You can have multiple jobs in the same workflow. They run in parallel, or you can create dependency between them. So for them to run in a certain order, and even pass down some arguments from one to the other. This is going to be shown on demo. So we just have like here on YAML the jobs list, and then the job name. Next on is the runner. So the runner is the machine that we're going to run our workflow. So we have like we can use GitHub hosted runners, and we have like 3 available environments. We can use Linux, we can use Windows and Mac. Actually, we have 6 because all of them, they have at least 2 versions. For example, Windows, they have like Server 2016 and Server 2019, and Ubuntu, they have like the 2 latest LTS versions. And we can have like self-hosted runners. So this is a machine that's hosted by the user. So if you need a specific like version of Linux that's not Ubuntu, or you need I don't know, any specific scenario. For example, if you want to build a Windows container using like Windows base image, those Windows hosted runners, they do not support Docker. So you need to have like a self-hosted runner, or maybe you have something inside your network that needs to be used during the event, and it's not open externally, so you need like a runner that's connected to your network or something like that. So we add here like on our job as runs on. One thing that you notice is that we're almost always we try to reach out to use Linux. There is certain limitations that I'll be talking soon to relate to Windows and Mac. Now the steps. So the steps, the smallest part of the of the of the workflow. So it can be either an action or a shell command. So you can run like a bash script or like a PowerShell script or something like that. Or you can use an action, and this as you can see here, it's using like the steps. You can name them or don't, and you just run this. So like right here, we can see like these uses is when you are using an action, and the run is when you're running a shell command. And then we have the actions itself. So the action is like a portable job that you can carry between workflows. And we have three types of jobs. So it can be a Docker container action, which is only supported on Linux. And that's why I said that we prefer to use Linux images to run our workflows, because we don't have like a limit of the actions we can use. It can be a action written in JavaScript. So this must be like a pure JavaScript code. And this one right here just runs straight into the runner, while the Docker container action, it builds a container inside the runner. So the JavaScript is much faster, but the container one is when you have like you need a different environment. So for example, you need to run a Python script, and you have a lot of dependencies, package dependencies, and you can just install those dependencies on your Docker file while building the container. So your script, you don't have like to have like a bunch of steps installing those dependencies. And then there is the composite action. This I never can say this right. The composite action, which like basically an action composed of other actions. And then you can create your own actions, or you can use one of the created by the GitHub community. So we have a marketplace on GitHub, and that can be used for that. So here I'm just showing the actions that are something that's important is that those actions, they can support input parameters, and they can also output some variables to be used in our workflow. And now is the demo. Just before we start the demo, quick disclaimer here. I'll be showing some demos and the codes and pipelines that were just created for this demo, just to show. They might not be like really useful, or you may call me dumb before doing something, but I'm trying to show as many features as possible on this. The codes can be found on GitHub. It's github.com/GitHub Actions Hangouts. And here I have the link to the GitHub Actions documentation. So let's go for the demos. So first of all, what I want to show is the marketplace, and something that that I think that's really cool for that GitHub has is if you don't have an action on your setup on your repo, it looks for the code for the language you have on your repository, and it has some like templates that can be used. So right here I have like a .NET application, so it's showing here a .NET pipeline, or I have a Docker file, so it has like a Docker. So if I click on set up this workflow, you can see like this is like the workflow that we were building in the slides. So it's basically a .NET. So it's the steps is just like checking out the repo, setting up .NET. Yeah, so this is something that it's important to note, is that we're always, when we're using GitHub Actions runners, we're always dealing with like a fresh install. So all dependencies must be installed. So you need like setup.NET, setup Python, setup Node every time you're running a job. Then restore independence and build. So this, and here we have like the marketplace. So let's say that I wanted to add like, I want to push this to Azure Blob Storage. Then I can just look here and find like an action that might help me out. So I just would need to, it has like the documentation parameters. I would just need to copy those to my pipeline and see like add the parameters that are required here. So this is really straightforward. So if I have like if it was like a container template, I could just like go and deploy to AWS ECS. So just deploy my task to run on cloud or something like that. So this is something that I wanted to show, and now I'm going to show. Oh yeah, the actions I have here. So first of all, I have a test pipeline. So I think it's better to show here on Visual Studio Code. Let me try to. I don't know if I can increase it, but as you can see here, it's can be triggered manually or when someone creates a pull request to the main branch. Then we have my jobs here. So I just have like a single job that's to test. It's running on Ubuntu. And then we have the steps like I showed before, checking out the repo, setting up the .NET, restoring dependencies, running the tests, and then I have this action right here. So what these actions do is we can add conditions to your steps. So these actions, it's set to always runs because I want this to run even if my test fails. But this will only run if the event that triggers this pull request is the triggers of this event is a pull request. So what this will do is to publish the results to my pull request of the test. So what I'll do right now, I'll raise 2 pull requests. I have like 2 branches, one that will fail. And one that will work. So as soon as I raise both pull requests, you can see here that I have like a check on my pull request. So this task, this job must complete successfully for this to be for the merge to run, for me to be able to merge the code. So both are triggering right now and running. So they I created really simple. So they shouldn't take like a minute to run. So you can see here that we have like the error code and error. Okay, so the first one failed, the one that had like a test that should fail. So here are the results. Like I said, it added a comment here on the pull request that we have like 4 tests, 3 passed and 1 fail. So, and if I click here to show like for me which tests fail, and I can't merge this branch because my test fail. Now if I go to the other one, you can see it's green. Here all checks have passed, all 4 test runs, and all of them worked. So I'll just go and merge this. I don't have someone to review it, so I'll just force the merge. And now as soon as I merge the code, my build pipeline is triggered automatically because, as I can show here, it's set to trigger automatically on push to my main branch. And for this one, so here is where it gets kind of weird because it's something that I created just for showing. I created like 3 jobs here. One is to get like the repo name. So I'm using like GitHub variables to get the repo name. So this is going to be used to create like my package in the end of the build process, and the build number. So these 2 jobs, they don't have like any dependency between them, so they can run in parallel. And this one that's going to build, then I created a dependency for them. So now let's go to, so let me show here. It ran already. So you can see here that those 2 ran in parallel, and we have like this dependency bond, this bond here between them and the build one. Another thing that I created here is I've created a setup.net action. So like I said before, those actions can be a composite action, which you can see here. And what this is doing, it's just basically doing the .NET setup and .NET restore, and it's I added this here just to show to you guys that the action can have like inputs and outputs, but this is basically like the worst version generator ever. So this is basically just getting the build number and add like a 0 before and a 0 after. So you can see here my action. It's always an action.yaml file, the name of the file must be his. And when you're using like a local action, you must specify the path to that action, to the folder of that action. And here we have like the inputs. I'm passing now as an argument the .NET version and the build number. And we are outputting the version that we desire to build our application. So as you can see here, I'm using the build number that's coming from this dependency, and .NET version using 5.0. Then I'm building the solution, and pushing the artifacts. So here I'm using an action. So this is an external action. Those actions that is set to actions here are actions made by GitHub. So this one is just uploading the artifact to the workflow itself. So if I go back here to my workflow, you can see my artifact here, the Notifier API and the version 0.25.0. So I showed to you guys like my test pipeline, my build pipeline. Now I want to show something kind of more complex. I showed on the presentation a few of the components, but not all of them are there. And to explain the next one, that's this integration one. I need to explain a little bit of what this application that I created do. So I have it running here. I also have like a net server running on my machine. So this is running locally on my machine. So my API just have like a single API. Like I said, it's pretty much useless. I can just pass down as an argument a topic and a set of strings separated by comma, and what it will do, like, and what this will do, it will just publish a message on that on the given topic, and one message for each of those. So if I execute here and we go for net, you can see here that it published like 3 messages: test 1, test 2, and test 3 on the test. So for this next pipeline, it's I wanted to do like some integration tests. So I want to test my application using like a real net service, and for that I'll be using a Python script. So here I have like this is a manual only workflow. We have like 2 inputs here. So I have like a default topic and a default message. So if I don't provide anything, those are the ones that are going to be sent. And what I wanted to show is this component here, that's the service. So whenever you need, and I chose to use nets here because it's really simple to work on with. You just have like to start the container and it's working. And if you guys don't know nets, there is on RDI YouTube channel, there is a video on it, like from like 1 or 2 months ago. That's really good. So after this, you should watch it. So Nets is a messaging service, and I want to run that service inside my runner. So I just come here and add services and nets, and I select the container image and like the port mapping that I want between my host and my and the container. So this can be used like for any kind of service that you need. Like if you have dependencies on a SQL database or like a Redis cache, so you can just run Redis container. So what this will do, so basically it will download the artifacts from my previous build. So here I'm using a community action. So if I just open like here a new window, and I can just find the code for this action right here. So all the parameters support documentation. So it's really easy to find it. Just 1 second. Sorry guys, I have a Roomba and it just started to work right now. So for this workflow here, this action here, I just add the workflow that I want to use to download the files. If I need this to be like this workflow to succeed before I download it, so I don't download from like a failed build, and the path that I want this to be downloaded. So this is the kind of action, like I said before. So this is a JavaScript action. It's using the GitHub APIs to download the files. So let's come back here. So I'm using a script here, a PowerShell script to start my API. And then I've created a container action. I'm just going to show you. That's going to receive like the topics and the message as parameters. And right here, I have like my action. So it's just going to start a container based on the Docker file I have here. That's just a Python container, and it will run pip to install dependencies. Like I said, all of dependencies needs to be installed on the Docker file. So this way we ensure that we have everything you need for it to run properly. And my entry point here. So here I have my action file. So it's next test. The inputs are topic and message, and those inputs are being passed down as arguments to my container. And so these arguments are added at the end of the entry point here on when running the script. So I'm not going to get too much into detail here, but basically what this does is it will subscribe to the topic that I send. It will send like a message, an API call to my .NET application, and we'll wait for those messages to be sent. And after those messages are sent, I'm going to just log a message. So if I go back here to my integration pipeline, like I said, I can run with like the default values we have here, or I can just go and create a new topic, and I like banana fruits topic, banana, mango, and cherries. One thing that is important to notice, there is a limit of how many workflows you can have running at the same time on the same repo. That's 2. So we can have like more than 2 jobs running at the same time. So let me open those here. So like I said, it's building download the container image, and it's build the container to run my action. So it takes some time, so that's why the JavaScript actions are quicker. So you only use these container actions when you need like a controlled environment, like we have here. It takes a few seconds for those container actions to run. Let's just wait a little bit. Yeah, so here you can see listening for requests on the names topic, and it logging that received the message on names and the messages. So this one is the same, like it's fruits, and then the messages, banana, mango, and cherries that I added. So this is what I wanted to show. I have one more thing to show. That's that I really like on GitHub. I'll be honest to you, I think it's really interesting. I never use it like in a professional way, but I plan to someday. And it's the support for matrix. So here I have like a Python script, and let's suppose that this script right here, we're going to run on some, let's say I work for the infra team of the company, and I'm going to run this on all of our employees' machines, but some of them use Linux, some of them use Windows, some use Mac, and they can even have like different Python versions installed on their machines. So I can use this matrix here to test if my script works for all those scenarios. So here I have my job, and I just add this strategy component here. This fail fast is set to false because if it's not set to false when running this matrix, as soon as the first one fails, all the others would fail. But I want to see like their results independently. So I create a matrix for OS here. So I have Ubuntu, Mac, and Windows, and I have like 2 different Python versions here. So as you can see here, I'm using the matrix OS on the runs on, and during the Python setup, I'm choosing like the different version. So what this will do is when I run it here, it's going to trigger 6 jobs, 1 for each of the matrix. So it will test like Ubuntu both for a version of 3.6 or 3.8 of Linux, and Mac and Windows. So this job I have right here, it's made to fail on purpose on Linux machines, just to show to you guys how useful this can be. So it's a script that works on both Linux and Mac, but it's not working on Linux. Sorry, it's working on Windows and Mac. I don't know what I said, but it's failing on Linux. So this would require more work to do. And I think that's all I had to show to you guys today. It went quicker than I expected. Do you guys have any questions? Things like nope. So I think that's all. Let's wrap it up here. Thanks everybody, and that's it.